Hello students. So we are going to start with our part 2 for our chapter force and laws of motion. In today's video we will be learning about Galileo's law. After that we will be studying Newton's first law of motion and then the concept of inertia. So these are the topics that we will be covering in today's video. So the next important question is that how Galileo's law corrects the Aristotle's law, that what the limitation was there in Aristotle's law, how this Galileo's statement removed that limitation, and how Galileo's law is better than Aristotle's law. See, what we have studied in Aristotle's law, it was to move in a uniform motion, you will have to apply some external force continuously. Fine? But Galileo's law says that a body can move in a uniform motion without any external force, but for this to happen, the surface on which this body is moving should be frictionless. Apart from that, the body should not face any kind of external oppositions. Fine? So in this way, Galileo's statement is far better and far more corrected form of Aristotle's law. Now after Galileo's law, there is another law that was given by Newton. Newton actually gave us 3 laws of motion. We will be studying them one by one. Actually Newton's law, they are furtherance of Galileo's law. So Galileo's law forms base for Newton's law of motion. So next we will be studying the Newton's law of motion. We will move on to Newton's first law of motion. So here is the statement for Newton's first law of motion. According to this statement, a body at rest tends to remain at rest and a body in uniform motion tends to remain in uniform motion until and unless any external unbalanced force acts on it. So this is the statement of Newton's first law. According to this statement, if a body is at rest, it will always remain at rest, and if a body is moving in a uniform motion, it will keep on moving in that uniform motion until and unless any external unbalanced force acts on it. Fine? See, balanced force, they will not disturb the motion of any body. But if any external unbalanced force acts on this body, the body's motion will be changed, and its motion will not be affected until and unless any external force acts on it. So this is the statement of Newton's first law, and this law is actually a furtherance of Galileo's law. It is carried forward from Galileo's law, and this law is also applicable if we are neglecting all external forces such as frictional force or air drag. So this law will also withstand only if there are no external forces acting on this body. Fine? So in that case, a body at rest will always remain at rest and a body in motion will always remain in that uniform motion until any external force disturbs it. That external force should be unbalanced force. Until any unbalanced force disturbs it, that body will keep on moving in that uniform motion. If it is at rest, it will remain at rest. So this is all about the statement of Newton's first law. Now we will be studying a very important and very interesting topic, that is inertia. See, what we have studied in Newton's first law, it was that a body which is at rest, it will try to remain at rest, and if a body it is in motion, if it is in a uniform motion, it will try to remain in that uniform motion until and unless any external unbalanced force acts on it. Until any external force acts, that body will remain in its state. So this property of bodies to remain in their state of rest until any external force affects them, this property, this very property is called inertia. So how we will define inertia? It is a property of a body due to which it opposes any change in its state of motion. If a body is at rest, it will try to remain at rest, and if a body it is moving in uniform motion, it will try to keep moving in that motion only. So inertia is a kind of resistance which a body is providing to all those forces which are trying to change its state of motion. So the concept of inertia has arrived from Newton's first law of motion, and depending upon the state of body, the inertia can be divided into three parts. So the three types of inertias are: first is inertia of motion. That means a body which is in motion, it will try to remain in that uniform motion until any external force affects it. Second is inertia of rest. According to this, a body which is at rest, it will try to remain at rest. Fine. So body does not want, a body at rest would not want to change its position, to change its state. It will try to remain at rest, and it will oppose any force which is trying to move that body. Third is inertia of direction. So what is inertia of direction? That means if a body is moving in a particular direction, it will try to keep on moving in that particular direction only. Again, if you apply some force to change its direction, it will oppose that change. So a body moving in a particular direction would like to move in that direction only until any external force forces it to change its direction. Now, to understand the concept of inertia, we can take up number of examples which would explain how the inertia works. So first, we will be studying about the inertia of motion. Suppose you are traveling in a car. Fine. So when you are traveling in a car, you are actually in a motion. Fine. So when you are in motion, your body is in motion and car is moving on a road, and suddenly if you apply the brakes, what will happen? If suddenly the brakes are applied, if you are sitting in the car, you will fall in forward direction. So why you are falling in forward direction? The reason is the brakes are applied to the car, fine, but your body, it was in motion, and your body wants to remain in that motion, but the car has suddenly stopped, but your body would like to move in forward direction, fine. So your body, it will resist that change. It will want, your body would want to keep on moving in motion only, but the car has stopped. Therefore, when suddenly brakes are applied, you tends to fall in forward direction. You will come in the forward direction. Fine. You can also take up the example like when you are standing in a bus and bus is going at some certain velocity, and if suddenly brakes are applied, you tends to fall in the forward direction. Why you are falling? Because your body is in inertia of motion. So your body want to remain in motion, but the bus has stopped. So your body want to remain in that motion. That is why you will fall in the forward direction. Here you can take an example like you are standing here in a bus, and if this bus stops suddenly, see, when this bus is moving, the bus is in motion, your body is also in motion, fine. So your body has inertia of motion, but when the bus stops suddenly, your feet, which are in direct contact with bus, they will stop, but your body would like to move in the forward direction. Your body do not want to change its state. So your body, it will go in forward direction, and your feet, they will stop because your feet are in direct contact with bus. So in this way, you will fall in forward direction. So this was your initial position when bus was traveling, and when bus stops, your feet stops there only because they are in direct contact with bus, but your entire body, it has fallen in the forward direction. In this way, when bus stops suddenly, you tend to fall in the forward direction. So this is all about inertia of motion. Similarly, we have inertia of rest. To explain the concept of inertia of rest, suppose you are standing in a stationary bus. So when you are standing in a stationary bus, what is happening? Bus is at rest and your body is also at rest. So your body has inertia of rest and your body would want to remain in rest only. Now you are standing in the bus and your body has inertia of rest. Now, if the bus starts moving suddenly, what will happen? Now, your body has inertia of rest. Your body would want to remain in rest. But when bus starts moving, what will happen? Your feet are in direct contact with bus. So your feet, they will move in forward direction. But your entire body, it would like to remain at rest. So your entire body will want to remain at rest, but your feet, they will move forward with the bus. That is why you will fall in the backward direction. So when suddenly bus starts, you tends to fall in the backward direction. So this is the example of inertia of rest. So this is how you will be falling in the backward direction when bus starts suddenly. So third example would be coming from inertia of direction. You must have experienced it. Suppose you are sitting in a bus, you are sitting at a seat, and the bus is moving in a particular direction. Suppose the bus takes a sharp turn. So when bus is taking a sharp turn, it is changing its direction. Earlier the bus was moving in one direction, so your body was having a particular inertia of direction in one direction. Fine. But when the bus is taking a sharp turn, what is happening? Your body, you must have experienced that when bus takes such sharp turns, your body tends to get bent in one direction. Suppose the bus is taking a turn in this direction, your body will bend in opposite direction. You must have experienced it in your school buses and other vehicles. Fine. So when bus is taking a turn, suppose in this direction, your body would like to remain in the same direction only. That is why if bus is taking turn in this direction, your body will tend to bend in this direction. So these are three inertias. Based on these, you will be getting number of questions, number of concept based questions, which will be explained by using these three kind of inertias. So with this, we will wind up today's video. We will be discussing Newton's second law and third law in our next video. Thank you.